Today we're going to look at graphing quadratic inequalities. So let's start by graphing this equation, y equals x squared plus 3x minus 4. So one way you could do it is just set up a table, and I've got a table set up for you here. So I encourage you to copy this down, maybe pause the video and then fill in the table. And so you just plug in the x values. So if we put negative 4 in for x, we get 16 here, plus negative 12, and then minus 4. We end up with 0 for y. If we put negative 3 in, we get 9, plus negative 9 minus 4 is negative 4. And so like a good chef, I've got my next step all ready for you. And so here's our table, and let's graph this parabola. So negative 4, 0, that would be right here. Negative 3, negative 4 would be right about here. Negative 2, negative 6 would be here. Negative 1, negative 6 would be here. 0, negative 4, 1, 0, 2, 6, and 3, 14 is somewhere up here. So let's draw this in. And the nice thing about parabolas is they're nice and symmetric. And so if I know this one is on the x-axis and the next one over is 6 up, I'll just make this one over 6 up. So let's graph it. So I'll just connect the dots. Ooh, yours would be a little bit better than this. Oh, that's terrible. Let's start fresh. Okay. This is looking better already. Okay, and I know the vertex is going to be between these 2 points. It doesn't just level off, so it's going to dip below there a little bit. And then we'll come up. We'll go through this dot, and then it's just going to keep going up. So we'll just kind of put some arrows on it. Okay, so there's our parabola. So it's just graphing. It's not much different than graphing lines. You just end up with a curvy shape instead. Okay, so the next question is, how do we graph if its y is less than that equation? So it's the same thing. You have the same table. You have these x values and these y values. You just graph them. So let's connect the dots again. I'll regraph the points. So negative 4, 0. Let's double check my graph here. Negative 3, negative 4. Negative 2, negative 6. Negative 1, negative 6. Negative, ooh, that's not negative 6. It's negative 5. Negative 6, negative 6, 0, negative 4, 1, 0, and then this was up 6. 1, 2, 3, 4, 5, 6. Okay. So it's the same thing, but what do we do with this if it's less than? So let's do a quick review on how to graph that stuff. If it's less than, you shade below the dotted line. If it's greater than, you shade above the dotted line. If it's less than or equal to, you shade below the solid line. And if it's greater than or equal to, you shade above the solid line. So probably pause the video, copy this down, make sure you have this in your notes. And so our problem is a less than problem. And that's telling us to shade below a dotted line. So when we draw this in, instead of making it a solid line, we'll just kind of make it a dotted line as we go. And if you get stuck, or if you end up, while you're doing the homework, you draw in a solid line accident, just make sure you're doing pencil, and just erase every once in a while. Okay, so we've got our dotted line drawn in, and then we're just going to shade below. So that means we're going to shade under this parabola. And so what does that mean? That means any of these points in this shaded area are going to make this equation true. So I'm just going to pick one out here. Looks like over 3 up 0. Let's test this point right here. This is 3, 0. So I put 3 in for x. So what I'm saying is 0 is going to be less than 3 squared plus 3 times 3 minus 4. I just randomly picked this one. You could have picked something over here if you really wanted to. You could have picked one of those points. So is 0 less than 9 plus 9 minus 4? Is 0 less than 18 minus 4? Is 0 less than 14? Yes. So this is true. So anything out here would be a solution to this inequality. And so if you forget, or if maybe it's not so obvious what's above, what's below, then maybe what you could do is just test a point inside, test a point outside, and if the inside one works, then you'd shade inside the parabola. If the outside one works, then you'd shade outside the parabola. And most legitimate math teachers explain it that way, rather than above and below. Okay, so let's graph this one. This one's already in vertex form, and so I'm going to locate the vertex. The vertex is at 3, 5, over 3, up 5. And typically, a parabola goes over 1, up 1, and then over 1, up 3, and then over 1, up 5. It always goes up by the next odd number. But this 2 out in front here, this is telling us it's going to go, instead of over 1, up 1, it's going to go over 1, up 2. It's a vertical stretch is what this is called. And then instead of going over 1 up 3, it's going to go over 1 up 6. So it's going to be way up here somewhere. Okay, it's greater than or equal to. That tells me it's going to be a solid line. So I'll draw in this solid line here. And then if it's greater than, that means I'm going to shade above it. So I'm going to shade inside this parabola. So everything inside the parabola is going to be a solution to this. And once again, I do want to check this just to make sure it does work. So it looks like over 3, let me grab another color here. Over 3, up 1, 2, 3, 4, 5. We'll say 3, 7. Does 3, 7 work? So is 7 greater than 2 times 3 minus 3 squared plus 5? So is 7 greater than 2 times 0 squared plus 5? Is 7 greater than 0 plus 5? Is 7 greater than 5? Yes. And then one thing you might want to do, rather than picking a number that you think is right, just pick 0, 0 every time. Because that's an easy one to plug in. So then you end up, so it just makes your math a little bit easier, I guess. But you can pick any point on this graph to test which part you would shade. Okay, so that is graphing quadratic inequalities.